Alright, welcome back to my channel where math is made easy. So today, what I'm going to be looking at is special systems of linear equations. Alright, we would have already looked at how to solve linear equations. So what we're going to be looking at are the different solutions. We would have explored getting one solution where it looks like this, where the two equations or the two lines intersect. All right, before we go further, I want you to tell me where you're watching from, and please remember to like, share, and subscribe. Let's go right in. So we have the one solution, and we have what is called the no solution, and we have the third one where we have infinitely many solutions. All right, so we're going to explore what all of these look like as an equation written in the equation form, or if it's graphed. So the one solution is where it intersects. So you have that one point. Remember, the solution is usually where it's touching. So that one point right there. And then you have this where it's not touching, meaning it doesn't have any solution. And we have a third one where, if you notice, you're only seeing one line, but this is really a representation. Let me get a color there. This is really saying that it's another line sitting on top of that line. So that is why you're seeing one line. So this is why it's infinitely many solutions, because it's continuously touching, because the lines are really the same. So we're going to explore that real quickly. All right, so let's go into our first example. So for this one, what we're going to do is we're going to solve them graphically, and we're also going to use either the elimination method or the substitution method to solve it, just so we can see what it looks like if it's written in the equation form or if it's solved graphically. So first, we're going to solve it graphically. The first thing we need to do is to go in and graph each line. So the first line is y equals 2x plus 1. We have it in the slope intercept form, y equals mx plus b. It's already in that form, so we're going to use that to graph. All right, so we have our b, which is where it's touching your y. It's touching the y at 1. And then I'm going to use my m, so that's my m and my b, to find another point. So it's 2, positive 2, so it's going up. 1, 2, 2 times, and 1 across, right? And just to get some other points, I'm going to put some other points in, just to get my line a little bit more accurate, because I'm graphing with that. Now, that's my first line, y equals 2x plus 1. Let's go in and graph our next line, which is that. So it's going to be -5 right here, my b. And then it's m is 2, so that's 1, 2, 1 across, 1, 2, 1 across. I'm just putting in some points. Remember, you only really need 2 points, but I'm putting in the additional points so I can draw the line more accurately. Now, remember at the beginning of the video what I showed you. Notice what's happening here. The lines are parallel, they are not touching, right? And parallel meaning that they're going to continuously go on and on and on and never touch. So it means that it's not going to meet at any point. So because it's not meeting at any point, we have what we say is a no solution. All right, we have no solution because it's not meeting. That's what it looks like graphically. Let's see if we can solve this using the substitution method and show you what it looks like if we're using that method. So we're going to go, it says y is equal to, so I'm going to solve y equals 2x plus 1 in equation 2. All right, so I'm going to put this in equation 2. So that's y Anywhere I see y, I'm going to put that. So that's y equals 2x minus 5. So where I see y, I'm putting that. So that's 2x plus 1 equals 2x minus 5. Nice? I want to get my x's on both sides. On that side, so I'm going to subtract 2x on both sides. So I'm going to left with 1 is equal to negative 5. Now I want you to look at this. 1 is equal to negative 5. Is 1 equal to negative 5? No. So if when you solve and you get that, your result is false, then it's a no solution. All right? If the result is false, then it's a no solution. So if you're solving like this and the result is false, no solution. If you're solving graphically and it looks like this where it's not meeting, no solution. All right? So those are what you need to look out for. We're going to examine another special type. So let's look at this one. That one is not written in the form. So we're going to rewrite it in the form so that we can go ahead and solve, right? So I'm going to rewrite it here. So that's y is equal to 3 plus 2x, right? Because I'd have to plus a 2x right there, plus a 2x right there. Good? Now, I'm going to rewrite this one. So let me just graph it, and then I'll rewrite that one. So y, so get it in the form, so that's 2x plus 3. So it's going to touch it at 3. Right here is my b. And then it's up 2 times 1. Up 1. Right? Just want to have it being accurate. Nice? So that's my first one. Let's rewrite my second one. So I'm going to get rid of my 4x. So that's adding 4x on both sides. So I'm with 2y is equal to 4x plus 6. And that's going to divide through by 2. So that's y is equal to, let me take my time so I don't lose anybody, 4x over 2 plus 6 over 2. That's y is equal to 2x plus 3, right? We're going to go ahead and graph that. Now, if you notice, it's the same graph. We got y is equal to 2x plus 3 for that one when we rewrote it. So it's the same thing. So it's going to sit right on top of it. All right? If your graph looks like that, it's infinitely many solutions, as I would have explored at the beginning of the lesson. Now, let's solve it using another method to see what it looks like. So, for this one, I'm going to use the elimination method, all right? Because I think that's easier to use. So, I'm going to try to get my y's, right? I'm going to try to get my y's to be the same. So I'm going to go ahead and I'm going to multiply my y, my equation right here by 2. So my new equation is going to be negative 4x plus 2y equals 3. And I'm rewriting this one equals 6, right? Now, let's go ahead and I can eliminate And if you did not watch this video, I'll put the link in the description section so you can watch it, where we did the elimination method, and we also did a video on substitution method. I'll put those in the description so you can go ahead and look at it. All right, so let's look at this one. I'm eliminating my y's because they now have the same coefficient. You have to have them having the same coefficient or the opposite coefficient in order to eliminate it, right? So I'm gonna go in and I will have to subtract because I want to eliminate. So this is now going to become, let me change the color. A negative times a negative is equal to a positive. So this is now going to become a positive, right? So that's negative 4 plus 4. That's going to give me 0. Good? That's plus a negative. I'm sorry, this should have been, this right here should have been a 6 because that's 2 times 3. So my apologies for that, right? So that's that. It's going to give me a negative times a positive is going to give me a negative. So that's 2 minus 2. That's going to be 0. And then this again, a negative times a positive is going to become a negative. So that's 6 minus 6 equals 0. So 0 is equal to 0 now. Let's look at the result. 0 is equal to 0. Is that true? Yes. So even though we don't have any variables in the result is true. 0 is equal to 0. So that's true. When you have your result being true, it means that your solution is infinitely many solutions. I hope this video would have helped you. Thank you so much for watching. See you in the next video.